Good morning all. Today we are going to implement experiment number 3, the lab experiment number 3. The problem statement goes like this. The circuit breaker will trip if and only if the hair dryer is turned on, the microwave oven is used, all the lights in the room are on, or there is a short circuit in any appliance. We are supposed to implement this using relevant mux. The components required are trainer kit, and the mux is 8:1 mux 74 LS 151. Fine. So, let us consider first the variables to solve this problem. Let us represent the hair dryer which is turned on as A. On means high, off means it is low. The microwave oven represented by B. High means it is on, off means it is low. All the lights in the room represented by the variable C, where all the lights are on means it is high, off means it is 0. There is a short circuit in any appliance, let us represent by D. If there is short circuit, it is high, else it is low. Let us represent the output as Z. That means high if at all if it is been tripped, else it will be low. Once the variables are being represented, the truth table is to be written. So, the truth table goes like this. If at all the first row, let us consider all the input variables are 0, in the sense all the 4 conditions are low. So, output will be low, there will be no trip in the circuit, that is a short circuit break, there will be no trip. Second row 0 0 0 1, in the sense the other 3 components are low, the last component, that is the short circuit in any appliance, is given as high. So, if it is high, any one of the 2 condition is high, output will be high. So, like this, the truth table, you have to fill up all the entries of the truth table. When you come to the last input combination, that is 1 1 1 and 1, that means all the conditions along with the 4th condition is true, output will be true. So, represent now the truth table in the form of Karnaugh map and do the simplification. So, this is the Karnaugh map simplification. Using WEM technique, combine 2 rows as one single row and represent like this, that is first row, second row, the output you represent in the form of D, which is called as I0 or D0. I0 and D0 both are same. Second row, third row, call it as I1. Fourth row, fifth row as I2. Fifth, sixth and seventh as I3. Eighth and ninth as I4. 10th and 11th as I5. 12th, 13th as I6, 14th, 15th as I7. Once the output is represented in the form of D, fetch the values for I0 to I7 as represented in the slide. So, the pin diagram goes like this. It's 8:1 mux. It is 16 pin IC. So, this is 16 pin IC will be having 3 select lines S0, S1 and S2 represented by pin number 11, 10 and 9. So, it is nothing but input given as ABC. So, ABC will act as select lines for this problem. Fine. And VCC is 16th pin, ground is 8 pin. D0 to D7 is given by the pins, or it is given, should be given as an input for the pins 4, 3, 2, 1, like that is D0, D1, D2, D3. 15th pin to 12th pin, I4, I5, I6 and I7. So, connections are to be made. Okay, and the output is pin number 5. 5 should be connected to the output. Okay, so circuit diagram goes like this. So, you have I0 to I7, I0 to I6 is the value D. So, give the input D to all these input lines. I7 is positive 5 volts, that is plus 5 volts. Select lines are ABC, S0, S1 and S2. Output is nothing but Y, that is nothing but Z here. So, we will implement the circuit using the trainer kit. So, let us rig up the circuit. So, this is 74151, 8:1 mux. Okay. So, this is 16 pin IC. So, 8 pin on both the sides. So, as usual, place the pin in one of the IC base. Okay. So, I am placing one of the second IC base I am placing. Place it. Gently place it in the IC. Okay. Press the notch, push it down. So, IC gets locked into the IC base. According to the pin diagram, let us make the VCC and ground connection. 8th pin is ground connected. 16th pin is IC. So, you have IC being connected to 16th pin. Here you may say it is 20th pin, but since it is 16th pin, these 2 pins, these 4 pins will be neglected, or it will be left open. It is not to be used. So, 8 starts here, 9th, 10th, 11, 12, 13, 14, 15 and 16. So connect 16th pin to VCC. Okay, now connecting the select lines. Select lines are, as I mentioned, it is 9th, 10th and 11th. Okay, so S0, S1 and S2. S0 should be connected to C, S1 connected to B, S2 connected to A. In the sense, I am using the input sockets as 3, 4, 5, that is A, B and C connected to the select lines 9, 10 and 11. Okay, 11th pin goes to C, 10th pin goes to B, 9th pin goes to A. So connected in the reverse order. So now connecting the input lines, that is data lines, that is D0 to D7. Okay, D0 to D6 is the value D according to the truth table. D7 is plus 5 volts. So you have D0 is nothing but 4th pin, D1, D2, D3. It goes in increasing order and comes in the decreasing order. D0, D1, D2, D3, D4, D5, D6, D7. Okay, connect D0 to D. So this is taken to be D. That is 6th pin input, logic input is taken to be D, connected to D. All the remaining inputs up to D6 should be connected to D. So it is D1 connected to D. So you have one more extra slot being given here. So connect it to the same. So you'll get same input is given for both the input pins. D0, D1. So this is D2. So once again you can go on making the connection one after the other. Connected. So this is D2 connected to D. So this is D4, D5, D6, D7. D4 is also D connected to D. D5 is also D connected to D. D6 is also D. So all the D's will be connected to one single pin. Okay, now D7 is plus 5 volts. Either you connect it to VCC or you connect it to some input, logic input, and keep this high. So as soon as switch on, LED will be on and it is passing plus 5 volts to D7. So this is with the connection. Taking the output line, that is 5th pin, which is Y, connected to output pin. Any one of the output pin you can use. Okay, got the connections. I'll repeat. Okay, so 8th pin is ground, 16th pin is VCC, 5th pin is output line. Okay, S0, S1, S2, that is CBA. Okay, so S0, S1, S2 is connected to CBA or ABC. Okay, D is connected to all the input pins D0, D1, D2, D3, D4, D5, D6. For all these input D lines, input lines, data lines, it is D. So connected from D. Output line is D7. The D7 is one more input line, so connected to high. So keep this high when you switch on the system. Okay, so switch it on. So you can see here, high goes to D7. So the connections are being done. So to check the output, check the truth table. Okay, all the odd input values, that is 1, 3, 5, 7, 13, 14, 15. All this input, output should be high. So let us check it. So 0, 0, 0, 0 is low, 0, 0, 0, 1. One second. 1. Okay. So it is 2. 2 is low. 3 is high. 4 is low. 5 is high according to the truth table. 6 is low. 7 is high. 8 is low. 9 is high. 10 is low. 11 is high. 12 is low. 13 is high. 14 is high and 15 is high. So for all, so it is working according to the truth table, means the circuit has satisfied the output of the truth table, means the circuit is a proper one. Okay. So this is the implementation of 4 is 8:1 mux or a multiplexer circuit.